Welcome back. Today we are working on review number 7. It looks like sequence and series. This did get changed in your packet, so make sure you have the extra 3-page mini packet to go with it. Believe me, this one's easier than the one that's in the big review packet. This is just kind of a breakdown of the different types of sequences. Remember, sequence is a list of numbers that has a pattern. And you can have, in our course, arithmetic or geometric. From there, you have the explicit formula, which allows you to jump right to whatever number you want. Here's the formula for arithmetic. Here's the formula for geometric. Recursive definition means you have to count from the previous term and then use that to find your next term. What a lot of people missed on their sequence test, you have to have the first term, a sub 1, and then you have to say what happens to that. So keep that in mind when you're making your definitions. Then we did some adding. There's 3 ways to do it. One, you can just add up all the numbers. Then there is sigma notation. That's that one that looks like the E. So when you see the formula, it would just say N or I or X or whatever. The number you start and you substitute. And then the number up here, like say 7. That's the number you stop substituting. So it could go from like 2 to 7. So we will practice that as well. And then the last one, series, we have arithmetic series. And then geometric series formula. Now, in our packet, our Unit 9 packet, this formula looked like this. S sub n is a sub 1. And I believe we used B in our packet. So those 2 formulas mean the exact same thing. So here, we're just going to practice. That's all. And then on Delta Math, you're going to do some more practice on this. So this says, given the sequence 1, 3, 5, 7, answer the following questions. First thing, you got to look and see if it's arithmetic or geometric. Since this pattern is adding 2, it's arithmetic. So part A says, define the sequence using an explicit formula. So the formula for an arithmetic sequence is this. You have to plug in your first term and your common difference, which in this case is plus 2. So our formula is 2 times n minus 1 plus our first term, which is 1. This is our explicit formula. Now it says describe the same sequence using a recursive definition. You have to say what your first term is. If you don't, it's not a complete definition. Then to get any term, you do your previous number, and then what's happening to it. Here we're adding 2. This is your entire recursive definition. You gotta have 2 lines. Now part C says using addition, find the sum of the first 4 terms. So we're just adding. When you add those up, you get 16. That is the sum of the first 4 terms. Now part D says using sigma notation, find the sum of the first 10 terms. So for this, we're starting here first, all the way up to the 10th term. Now what is going to go in this parentheses, don't write this down because I'm going to erase it, is your explicit formula. So if we look up here, this thing in blue, actually without, this part is going to go by your summation. So 2 times n minus 1 plus our first term is 1. Okay? And then you can put that in your graphing calculator. I believe you can also use Desmos. You just type sum, S-U-M. And when you type all of that in, you get 100. Now, because it says using sigma notation on a test, you would have to do that for full credit. Now, part E says using the appropriate series formula, find the sum of the first 15 terms. So this would be S subscript N. This is our series formula. It's an arithmetic series all over 2. So we can only plug in so much. So we're finding the first 15 terms. Number of terms is 15. Our first term is 1. We have to find that term, our nth term, our 15th term. So for that, I'm going to use my explicit formula. And I'm doing the 15th. So plug a 15 in for n, 15 minus 1, and then evaluate that, and your 15th term is 29. Now at this point, we can just put this into our calculator. 15 times 30 divided by 2, and you end up with 225. Okay? Now part F, this is just a little bit more practice. Same stuff. Using both the sigma notation and the series notation, find the sum of the first 97 terms. So sigma notation, we're going to start with our first, and I'm going to use my explicit formula again. And since we're finding the first 97 terms, I'm going to put a 97 up here. And very carefully put that into your calculator, and you get 9409. Now for the series formula, I'm just going to copy it even though it's right up above us. We should still get the same answer, okay? So we're finding the first 97 terms. So the sum of the first 97 is n, our first term. We still don't know our 97th term. So here we have to find our 97th term. I'm going to use my explicit formula. Oops. 97. So it's D times 97. Whoops. 97 minus 1 plus our first term. And you get 193. So that goes right here. Put this part into your calculator, and you end up with 9409. Same answer. Which one was easier? That depends on how you feel. I think the sigma notation, because you didn't have to find the last term. Either one works. So now what you guys are going to do is page 22. It's the same questions, but it is a geometric sequence. So pause the video, come back to it, and check your work. Problem 2, given the sequence 1, -2, 4, -8, 16, answer the following questions. This is geometric. And your rate is multiplying by -2. Define the sequence using an explicit formula. So the explicit formula for a geometric sequence is first term times the multiply rate to the n minus 1. And you might see in formulas the R or the B can be interchangeable. So my formula is a sub n, first term times the multiply rate to the n minus 1. This is our explicit formula. Recursive definition, you have to say your first term. First term is 1. How to find the next one? You take your previous number and you multiply by -2. You could also put that -2 in front, so you could have you could have this. A sub 1 equals 1, a sub n equals -2, means the same thing, whichever way you prefer. Same as the other page, using addition, find the sum of the first 4 terms. So 1 plus -2 plus 4 plus -8. When you add those all up, you get -5. Part D, using sigma notation, find the sum of the first 10 terms. So sigma notation is our summation, first 10 terms. And remember, here we put our explicit formula, 1 times -2 to the n minus 1. When you put this in your graphing calculator, you use the X button instead of n. And when you do that, you get -341. Part E, using the appropriate series formula, find the sum of the first 15 terms. Now for a geometric series, this one's much easier. So we just say S sub 15, well, I guess I'll write the formula first. It's always good to write the formula. S subscript n, first term minus first term, rate, number of terms over 1 minus rate. So we would say sub 15, our first term is 1, -2 to 15. So 1 minus -2. And when you put that in your calculator, you get 10,923. Part F, using both notations now, find the sum of the first 97 terms. So our sigma n equals 1 to 97. Put your explicit formula in here, 1 times -2 to the n minus 1. And when you evaluate that, we actually get scientific notation, 5.28 times 10 to the 28. That means you move the 0.28 over and then you add 26 more zeros. It's a huge number. I'm not even going to go there. So now for series notation, 97, so a sub 1 plus a sub 1 multiply rate to the 97th term over 1 minus r. And when you put that in, you get the exact same answer. It's a big old number. So part G, which method was easier? It depends on the way your mind works best. I think series notation for geometric sequence is much easier than arithmetic because you didn't have to find your last term. Sometimes people don't like finding explicit formulas, so they think that's more tricky. But for letter G, it's kind of a to each his own thing. So go on to Delta Math, practice this, and see you next time.